welcome back to another video in this week's Java Data Structures tutorials. So in this video, we are going to be talking about TreeSet methods. So there are actually two pages for TreeSet methods. We're going to talk about page 1 in this video. Next video, which will come next week, we'll talk about TreeSet methods part 2 and how to loop through TreeSets. So, I just want to show you guys this meme that I found. When you finally write 10 lines of code without searching on Google, it's not much, but it's honest work. I think that's hilarious because so many people get into the habit of copy pasting, which I have nothing against, but just writing your own code feels pretty good sometimes. Okay, so let's jump right into our TreeSet method. So as a quick review from last video, we created a simple TreeSet. We used the .add function. We learned that duplicates are not added to the TreeSet, so let's go ahead and get rid of those duplicates anyways. And that the TreeSet is sorted alphabetically. So now we're going to be moving some things around, we're going to be manipulating our TreeSet a little bit. So actually, for the sake of practice, I'm just going to create a new TreeSet together with all of you. I actually do have to point out something new here. I think I have too many parentheses. There we go. Or brackets. Anyways, if you mess up your brackets, oh, terrible. Okay, so I do want to show you this picture. I highlighted a line in the first line. Do we notice anything different? Navigable set string TreeSet is equal to new TreeSet over here. Set string TreeSet equals to new TreeSet. Well, the difference is that in this case, I'm using navigable set. And so we're going to start off by just using a normal set. And then later, we're going to see why we have to change to navigable set. But I just want to bring to your attention right now that we did indeed switch. We did a little switcheroo and we switched these. So I'm going to go ahead, start with a set and create a new one and then add some values to it. Set string. I'm going to leave it as TS for now to make it simple. New tree set. And then parentheses. There we go. All right. So we need to start adding some values to our tree set. So this time, I'm really actually hungry right now, so I'm going to start doing some food. Most of these things actually in our previous set was food, but let's go ahead and add, I just had ramen today. Like, you guys know the ramen where you add your own like vegetables and like eggs and stuff to it? It's good, but today I had ramen, just plain unhealthy ramen junk food. It was so good. Okay, so ramen. And dumplings, and let's see, I'm really going with the pasta today, or like the dough. I don't know why, maybe I'm just feeling really healthy, really unhealthy. Let's throw something healthy in there. I've been trying to eat salad for lunch, so Caesar salad. I don't think I spelled that right, but it's okay. And let's add 3 more values in here. So we've had our food, we can give it appetizer. What do people usually eat for appetizers? I never order appetizers. I go right into the main course. There's no need for appetizers for me. Okay, so we'll just do some more main courses. So, gosh, guys, my brain is really blanking today. Can't think of anything that people normally eat. Oh, the other day at school, we had fair day, so we had fried zucchini, which I heard was really good, but I don't want anything to do with zucchini, so I did not even try it. We also have, this is a good one, powdered sugar strawberries. I just realized how good those things were. Oh, delicious, so good. Okay, one last one. We'll put a drink here. Raspberry tea lemonade. That is something that is a specialty of mine at school. We fill it up with lemonade halfway, and then we go and we take the raspberry tea and we fill it in little by little until there's this nice pink ombre going on. Really good at it, guys. All right, so now that we have our tree set, let's start manipulating it a little bit more. So let's go ahead and print out the original tree set just for us to register, just for us to compare things with. So we printed out our original tree set, and then I want to do the contains method. So in order to check if our tree set contains something, well, we have to give it a something to check for, right? We can't just tell it, does it contain? Well, what is it containing, right? So we're going to have to give it some sort of value to check. So string check. And let's first give it a value that does not exist in our tree set. So we really wanted to have waffle fries that day, but they didn't have any waffle fries. But we're still going to check. What if they have waffle fries, right? So string check is waffle fries. And then see if you can understand what I'm writing here. I believe you should. So let's see. Tree set contains plus check plus colon plus ts dot contains check. All right, so I feel like the only part that's kind of confusing would be when you mix up check and check here. But what I'm saying is that TreeSet contains waffle fries, and this value is actually going to return me a true or false. So if you hover over it, you're going to see, let me zoom out a little bit. This is going to return you a Boolean. Returns true if the set contains the specific element, and false if it does not contain it. I don't know where it says false, but it's going to give you false if it does not contain it. So let's go ahead and run the code. The first line should be the printed tree set, and the second line says tree set contains waffle fries false. So this is kind of like checking. And so how you can think of this statement is you could say, the tree set does contain waffle fries. That is a statement, and statements you can answer true or false, yes or no to that. So in this case, the tree set does contain waffle fries. Is that true or is that false? And that is actually going to be false. So let's do one more where it does exist. So let's do an easy one. Let's do pasta. That's easy to type. So we're going to say check pasta. Excuse me, sorry guys. So yes, we see that it says tree set contains pasta, true. So that means that we do actually have pasta in our tree set, which is correct, we do. So we learned about the contains function. I want to talk about the first and last function next. So this is where we're going to start to see why set isn't going to work. So in order to contain, to say first or last, that doesn't need to be compared to any sort of thing. All we can do is just say what is the first and what is the last of our set. Let's try and print it out. So ts.first, system.out.println, ts.last. Alrighty. Does everybody notice how these red lines don't seem to go away? And it's not a REPL thing. If I run my code, this is actually going to give me an error, 2 errors, because it cannot find the first and it cannot find the last. The reason being, set in this case isn't going to work. So that's where navigable set is going to come in. In order for us to be able to manipulate and change up our set a little bit more, we need to use navigable set. So we're going to change this to navigable set, and then immediately the red line disappears. You're good to go. So let's run our code one more time, and we're going to see that first in this case is Caesar salad, last is raspberry tea lemonade. I did not spell those words right. Okay, so first in this case is indeed Caesar salad, because alphabetically that is our first value, and last alphabetically is indeed raspberry tea lemonade. So these are very simple and very self-explanatory, because they're exactly what the names say they are. The next two are a little bit trickier. These are what people get mixed up on sometimes. So this one is higher and lower. Now, if I went up to you and just said, are you higher? Would you know how to answer that? Well, I would hope not, right? Because you need to compare your height to someone, or like your order to something. So in order to use higher and lower, we're going to have to give it a string, and we're going to have to get it something like check, but we can't name it check. We'll call it val. And let's give it another value in here. I'm going to give it fried zucchini. There we go. So this is fried zucchini. And then let's do this. Higher value plus ts.val higher val system.out.println lower value plus ts.lower val, and then semicolon. All right, so I want to run this code. Take a guess. If the zucchini is right over here, fried zucchini, what would be the higher and the lower values? Take your guess. Let's see if you're right. If we run our code, the higher value we get is going to be pasta, and the lower value we get is going to be dumplings. Now, if that was your guess, awesome. If not, it's okay. This was kind of a weird question. So, higher and lower. How do you differentiate higher and lower in our tree set? Well, that actually has to depend on alphabetical order again. So the higher the item, I guess, the higher it is in the alphabet. So basically, the higher down you are in the alphabet, the higher you are in this case. So again, what I mean by higher or lower, like A, B, C are like the lower values, X, Y, Z are like the higher values. So in this case, higher and lower, I do want to emphasize, they're always to the left and to the right of our value that we give. And so the higher one is always on the right because alphabetically the higher one is on the right, and then alphabetically the lower one is on the left. So that was for fried zucchini, for dumplings and pasta. If I changed this to, let's try Caesar salad. I want to see what it gives us as the lower value because we don't really have a lower value. So I want to see what it gives us. There we go. So higher value is dumplings. Yes, that's correct. Lower value is null. Why? Because we don't have anything that's lower than Caesar salad. Similarly, the higher value for raspberry tea lemonade would also be null because there's no higher value. Okay, so hopefully those made some sense. We talked about the contains method just to check and see if your value is actually in the tree set. First and last, simple, no explanation needed. Higher and lower, where you compare your value and then you find it to the left or to the right, depending on which one it is. So that is our video. These are the videos for this week. Next week, we'll talk a little bit about tree set methods, part 2, and looping through values in the tree set. And then maybe, if we have time, introducing a new data structure. So I hope you guys enjoyed these videos. I loved making them, and I'll see you guys next week. Bye, guys.